Human augmentation. It's one of the biggest, most exciting, and frankly, most debated topics of our time. And right at the heart of it all, brain-computer interfaces, or BCIs. You know, the tech that promises to unlock superhuman intelligence. But what if that entire premise is just wrong?
Look, we're all totally captivated by this idea, right? The thought of directly plugging into our own minds, getting smarter, faster, more capable all in an instant. It feels like the next logical step for humanity. But what if it's not?
So in this explainer, we're going to flip that whole idea on its head. We're going to explore this really groundbreaking concept that the best way to augment our minds isn't by trying to hijack the brain, but by supporting the incredible biological system it's already a part of.
Okay, let's dive right in. Now, to really get this counter-argument, we first have to understand just how huge the hype is around these invasive BCIs. I mean, this is not some niche sci-fi idea anymore. This is a full-blown, multi-billion-dollar industry in the making.
Yep, $12 billion. That's what the BCI market is projected to be worth by 2035. So this isn't just about scientific curiosity, you see. This is a massive wave of money and investment, all chasing this really powerful vision of the future.
And you can see why. The goals are amazing. Restoring function for people with paralysis, that is an absolutely noble, life-changing mission. And then you have the really seductive stuff, right? Ultra-high bandwidth communication, basically telepathy, all funded by hundreds of millions in venture capital. But the real question is this the only way to get there?
Okay, so that's the sales pitch. But when you pull back the curtain and look at the actual clinical reality, well, the picture gets a whole lot messier. Because it turns out the brain really doesn't like being invaded. This quote from clinical research is, well, it's pretty shocking, but it's also incredibly accurate. See, our brain isn't like a hard drive. It's this soft, delicate, kind of gelatinous organ. So sticking rigid silicone implants into it is, as these researchers put it, like inserting razor blades in gel. And the body's reaction? It's swift and it's predictable.
This table really just lays it all out. You can see invasive BCIs have high surgical risks and, this is the key, limited longevity. And why? It's all because of biocompatibility. The body's immune system sees that implant as a foreign invader and builds a scar around it, a thick, non-conductive wall called a glial scar. And over time, that scar just chokes off the signal, often making the device useless. That's the fundamental biological problem that the other methods just don't have to deal with.
And this is so crucial, that biological rejection, it points to a much deeper flaw in our thinking. The problem isn't just with the hardware we're using, it's with the entire philosophy behind the whole project.
The entire BCI hype train is running on this one, simple, convenient, and completely wrong metaphor. The brain as a computer. You know, the idea that we can just pop in a USB stick and upload some new software. It assumes our thinking is just a simple process of input, processing, and output. But what modern neuroscience is showing us is a reality that's so much more complex, and honestly, way more beautiful.
It turns out our intelligence isn't just locked up inside our skulls. It's distributed. It's something that emerges from this constant, dynamic conversation happening between our brain, our gut, and our heart. These systems are all woven together in this incredible network that creates what we experience as thought and consciousness.
And each of these hubs has its own unique computational style. So the brain is super fast, it's predictive. But the gut, it operates much more slowly using chemical signals. Think of it as providing all this essential context about the state of our body. Are we stressed? Are we hungry? The brain needs that information to make sense of everything. So if we try to just jack directly into the brain, we might be completely missing the most important parts of the conversation.
So if hijacking the brain is the wrong way to go, what's the alternative? Well, it's a pretty radical shift in how we think about it. Instead of trying to force our way in, we use the body's own amazing pathways as the ultimate interface.
I know, it sounds almost too simple to be true, but this is where it gets really brilliant. Researchers are creating smart textiles, like these computable socks. They monitor how you walk in real time and can even give you these subtle little bits of feedback, which enhances your natural sense of balance. You're not overriding the brain's code, you're just giving it better data to work with.
And this idea of using our skin as an interface goes way beyond our feet. These are thin, flexible patches that can deliver really complex sensations to any part of your body. This allows for something called sensory substitution. So, for example, you could map out a room into touch for a visually impaired person, letting them feel their surroundings without ever needing to touch their brain.
You can even use this same tech to create a kind of virtual reality right on your skin. I mean, imagine getting precise feedback from a prosthetic limb that makes it feel totally real, or an athlete getting coached on their form through targeted vibrations. We're talking about expanding our sensory world, not just our computational one.
And we can still give the brain a direct boost, just without the surgery. There's a technique called photobiomodulation that uses near-infrared light to ramp up the energy production inside our brain cells. So instead of adding some foreign piece of hardware, we're basically supercharging the brain's own biological engine, letting it run at its natural best.
And all of this brings us to a really critical choice. Because the path we decide to go down, whether it's invasive hijacking or non-invasive support, it has huge implications for the future of our species. This is not just a tech debate anymore, it's an ethical and an evolutionary one.
The biggest danger with the invasive approach is something called cognitive standardization. If a BCI needs your brain to fire in a specific pattern to work, it forces every user's brain to conform to the machine's rigid logic. That is the exact opposite of neuroplasticity, the brain's amazing ability to create unique pathways. We literally risk flattening the very diversity that makes human intelligence so powerful in the first place.
This slide really breaks down the dangers of what you could call neurosteering. If just a handful of corporations control the standards for these brain interfaces, they could get an unprecedented amount of influence over how we think and how we behave. We could be facing a future where our own thoughts are no longer private, our neural data is sold to the highest bidder, and the rich get cognitive upgrades that create a kind of biological caste system.
And you know, if we think about our future off-world, the choice becomes crystal clear. On a 3-year mission to Mars, you can't exactly perform emergency brain surgery. An infection or a device failure would be an absolute catastrophe. The future of neurotech in deep space has to be non-invasive systems that are robust, reversible, and above all, safe.
And that really brings us to the final takeaway here. Maybe the most radical, the most sophisticated, and the most powerful form of human augmentation isn't about becoming part machine at all. Maybe it's about building an ecosystem of technology that protects and nourishes our own incredible biology, letting us finally see what our brains and our bodies are truly capable of all on their own.